Thank you all for standing by, and welcome to today's webinar, Network Security Automation with HashiCorp Consul-Terraform-Sync and Palo Alto Networks. My name is Karen Hui, Senior Partner Marketing Manager here at HashiCorp, and I'll be helping facilitate today's webinar. Please feel free to type your questions in the Q&A feature during the webinar. This webinar is recorded, and the recording will be made available after post-processing, usually within 2 days. Our speakers today are Megara Kanyake, Global Solution Architect Security Automation, Palo Alto Networks, and Nathan Pierce, Consul Specialist, HashiCorp. They'll be talking about the impact of Consul-Terraform-Sync on network infrastructure automation and how HashiCorp, together with Palo Alto Networks, can embed consistent and frictionless security into your multi-cloud or hybrid environment. Please feel free to reach out directly to the speakers via Twitter for any follow-up questions as well. And now let's get started. Here's Nathan, who will start the presentation. Thank you, Nathan.
Hi, thanks for that intro, Karen. I'm Nathan from the HashiCorp side. I've been a little obsessed with any kind of network infrastructure automation for most of the last 10 years. It's very cool to be working on that at HashiCorp and Consul, and with Consul, I'm really excited about some of the innovations that we've released and GA'd recently in the partnerships that this is helping us form to solve big customer problems. So first, I'm just going to get into like the problem that drove the need for this change in organizations. Then we'll take a look at how the integration works, and then we're going to see a fantastic demo from Megara. Hopefully, he's sacrificed a bucket of chicken to the demo gods, and everything will go fantastically. So first, how did we get here? Why are we doing this? What caused all of this? I think everyone's fairly aware of this cloud thing. I'm hoping we don't have to go much into this. There's been a significant change in the way that we deploy and manage and deliver services and applications on infrastructure. And that infrastructure has changed the way that we operate. And the freedom and flexibility that that infrastructure has brought to us has enabled evolutions in the way that applications are developed and delivered. These static monoliths, not much of a thing these days when designing applications, and it's more about the benefits of agility and flexibility we get from smaller moving parts, from agile dynamic microservice. It enables us to do things like A/B testing in production without having huge impacts and outages and change windows. So fabulous evolution that's come out of all of this. And as a huge part of this, the way that we operationalize this process of getting things to market was the need for this big change in the way that we deployed. That was the birth of this concept of DevOps, that a term used a lot. Quick history lesson for those who didn't know where all this came from. 2009 Velocity Conference, Paul Hammond and John Osborne delivered a presentation deploying 10 times a day. At that time, 2009, that seemed like a crazy idea. We did deployments a couple times a year, and they were very controlled. And that's where it all began. That presentation was called Dev Plus Ops, which evolved and changed into DevOps. But the idea being that we reduce operational friction. That is the key theme. And I wanted to just have this quick reset that we're all on the same page with that goal, because as with anything through generations of marketing, terms get they evolve and they change, but the goal behind all of this is operational friction. How can I get revenue generating or productivity improving services to their desired consumer as quick as possible and get everything out of the way that might prevent that? So that is the general theme about this partnership, and let's talk a little bit about what that's looked like. So DevOps set out to give us this pattern, reproducible and reliable patterns for continuous deployment. How can I get this new service generating revenue, improving productivity to the intended consumer of that service, but do it in a way where it's reproducible. I can keep doing it, I can keep deploying it. If anything breaks, I can redeploy it again somewhere else. How can I get operational friction to be a thing of the past? Now, we've heard a lot from DevOps messaging and media and blogs and new companies, many new companies formed out of this space. Continuous integration was a magical new thing. Checking code, automated testing pass, merging with branches. But a key thing to understand, I think this is lost in a lot of communications about DevOps, this CI/CD acronym. There's more than one CD. There's continuous delivery and there's continuous deployment. And for most organizations, continuous delivery, the production of an artifact, a binary, a framework, or a container, that was very achievable because it crossed fewer boundaries. Unfortunately, though, that space typically stopped, and then we still had manual deployment, because the evolution of DevOps focused very much on the production of assets and not how to get them in front of consumers. And what this did, this shone a huge operational spotlight. There's that CI and all that wonderful automation on the left in the delivery process. And then we still mainly manage things by the CLI and the GUI. That's why we have this delayed, or what I like to call the third CD of CI/CD, continuous disappointment. So all this work has been automated up until this point, but we're not getting to the desired service consumer. Now, this shone a huge spotlight on the security and network operations departments. Like, why aren't you enabling the extension of this continuous delivery so that we get to continuous deployment? And the industry responded fabulously. We saw tooling from vendors specific around managing the individual products. We saw huge evolution in Python. Like, suddenly everyone who was using a CLI learned how to write some Python and automate their task, but that's the key element there. It was task-based automation. A process I would write in the CLI every day of the week, I would now automate, but I still had to run it. I still had to give it valid input for it to be successful, and it was still reliant on my input being correct. I could still break stuff and cause an outage. I could put the wrong IP address in and put some development service on the internet by accident. We sped things up, but sped things up for people. And as one of my favorite Elon Musk quotes goes, the moment you put people in the production lane, everything slows down to people's speed. So this was fantastic. I don't want to be negative about the huge evolutions of automation that's gone on within network and security, but there's still this gap. We really just kicked the continuous disappointment can slightly down the road. And this is because we still have this manual handoff. We still have tickets. We still have the manual processing of when to make a change and what that change needs to be. Now, it's fun to beat up ITIL. I remember those days, and I remember earlier in my career helping people write those deployment documents. We would print them out and stick them in a binder. Remember printing and binders? That's how we used to deploy stuff. Tick this box, do this. It still took days to deploy things. ITIL wasn't the problem. It's the implementation of ITIL. Like reproducible process, accountability around that process, that is absolutely the goal around systems thinking, around automating this entire end-to-end. It's just taking out the need for a person to be involved in every single transaction. That's the goal here. That's what we need to change. Good news. So getting to this, okay, well, it obviously means we can't do things the way we've been doing. Spreadsheets, even platform-specific tooling, multi-cloud. You've got multiple platforms. Now I've got two different sets of information to manage. None of these are really fit for purpose of this process. We already have a state that is the application running. So why then take that state and manage that in another system again, another spreadsheet, another database, or somewhere else? We're now double handling information. So the way things done, the tooling even, it just isn't right for solving this problem, for getting this job done. Fortunately, something is, and that's what this presentation is about today, what Consul brings to this workflow to eliminate that continuous disappointment and to streamline and automate in a very reproducible pattern without introducing lack of security, without weakening security posture. And that's why we have fabulous partners like Palo Alto to ensure that end-to-end solution goes out without it being weaker than what we had before, without bringing something in that was lesser. In fact, it's stronger than what we had when we had the human intervention and interaction happening in the middle step there. Now, I don't expect everyone to know what Consul is. Maybe you've been living somewhere without the internet for a couple of years. Who knows? So let's have a quick recap. Consul, very, very quick overview, has two elements to it: a highly available, all-active cluster of Console servers, that is where the service catalog resides, the state of the applications and services. And then we have the applications and services themselves, which run a console agent. That agent is constantly monitoring the local health and availability of that service, and it is propagating that information into the cluster. So we now have an always update, up to the millisecond visibility of all of our apps and services, where they are, how to get to them, and to ensure that when anything requests access to a service, we're giving back a reliable, accurate destination for them to get to. Very important, this is, when we hear the word things like service mesh, we think, oh, that must be, no, this is designed very differently from many of the solutions out there, in that it's multi-platform, not just multi-cloud. So Console supports all your bare metal, virtual machine, container, Kubernetes, all those environments, and actually can provide the interconnectivity, easy for me to say, between all of those systems and solutions. So super quick recap there of just what Console is. Supports multiple use cases, like service discovery, service mesh, multi-platform service mesh. Today, though, we're specifically talking about service discovery and using that as an event trigger whenever that state is updated or changed to impact the networking infrastructure in front of it. So that is what we mean at HashiCorp when we talk about network infrastructure automation. You have your day 01 automation, so you might be using Terraform. In fact, it's probably quite likely you're using Terraform to create things like your Palo Alto VM series. It's a fantastic way of kind of booting that up and stitching it into the network that's around it. That's your day 01 kind of task. But then the problem is once it's deployed, what happens after that? Day 2 operations. That is actually the long tail of pain that every time something gets changed, every time I change a scale group, I've got to do something about that. And that's very difficult for organizations. And it's never ending until that application's retired. So that initial pain of deployment is, I would actually argue, almost insignificant compared to what the ongoing operational pain can be after deployment. So we're showing you today how to solve that post-deployment operational pain. Okay, now I'm going to hand over to my awesome buddy here, Megara, on the other side, to talk a little bit more from the Palo Alto side of things.
Thanks, Nathan. Hello, everybody. Just let me introduce myself real quick. I'm Megara. I work for Palo Alto. So I'm working within the professional services organization. Usually my job include helping our customers to deploy our products adhering to the best practices, and also working with great partners like HashiCorp to make sure the integrations work smoothly and make sure those integrations benefit our customers. So before we dive into too much detail, I want to quickly focus a little bit here. So if you think about the cloud operating model from HashiCorp, so you got different tools provided by HashiCorp, right? Like Terraform for provisioning, Vault for securing stuff, and Consul for connecting those services, and of course, tools like Nomad for deploying these your services. Now with Palo Alto on the right-hand side, we can deploy these our products parallelly to this HashiCorp tooling to make sure your cloud workloads across multi-cloud or hybrid cloud are secure. So if you look at Prisma Cloud, which will provide you full lifecycle security. So this includes from the day you start to write your provisioning code, for an instance, maybe using Terraform. So we got awesome tools to make sure that that code you write, the Terraform configuration, is properly scanned. So you make sure there's nothing too much exposed. Or you might be downloading some of the code from public registry. There are thousands of modules available, right? So it's really important to make sure that the code that you're using is properly written, systematically analyzed. So products like Prisma Cloud would definitely help that. And not only that, also provide that full lifecycle security throughout. Today, we're going to mainly be focusing on VM series firewalls. So these are our virtualized firewalls running Panos. So you can run these firewalls across multi-cloud or hybrid cloud. So the customers get that protection you had on-prem now across multi-cloud. So just want to talk a little bit here. Usually customers start deploying their services maybe in one cloud provider, and then before you even realizing, you start to deploy more and more services across clouds, right? And then you might also want to maintain some of the services in your on-prem, right? Or maybe your private data center. So this is where the VM series and the hardware firewalls, that nice common control plane really benefit our customers. Our joint customers start to come to the realization it's really important to have that common control plane. And with Panorama, our management platform, you can get that single pane of glass, right? So you also have a common management plane across your multi-cloud and give that consistent security. Want to talk a little bit about the existing integrations with HashiCorp. Currently, we got 2 Terraform providers. So the main one that we're going to use during our demo today is Panos provider. This allows you to control Panos-based firewalls. So this could be your VM series or hardware firewalls. And then we also got a Prisma Cloud provider, which allows you to control some aspects of Prisma Cloud. Also worth noting, if you're using HashiCorp Terraform Cloud, we've got integrations with Bridgecrew, so you can ensure that code that you're pushing through are adhering to certain rules, or just making sure that you're actually deploying code that you should be deploying. With Vault, we got an integration with Prisma Cloud. This is where you can not hard code credentials or secrets within your container images. Very important, right? So where you usually write container images, Docker files, maybe you're publishing it. One of the common mistake that we see, customers hard code these credentials into these Docker files. So with Prisma Cloud and Vault integration, using Vault key value store, we can dynamically inject those secrets into those containers that get spun out. And lastly, but not least, Consul-Terraform-Sync. The whole presentation today is going to be focused on this, how we can seamlessly integrate, use that Consul service catalog as single source of truth, and how to drive the metadata coming out of that Consul service catalog and push that metadata as dynamic IP tags. So what's new? This week we released Palo Alto Networks Terraform modules. These modules are written adhering to the best practices. These are the modules that professional services use to VM series firewalls in Azure Cloud for our customers. So we want the community to benefit from these modules. So these are now open source. You can consume this through Terraform registry. We would love to hear your feedback. Please go to our GitHub page, start GitHub discussions, open issues. Would love to hear the feedback. All right. So I'm going to pause here real quick. I'm going to hand over to Nathan just to quickly go through what are the bits and bobs here.
Yeah, thanks, Megara. So the far left here, that console icon, that's representing Consul's service catalog. It's obviously a less complex diagram than I had before, but that's that state, that constant updated visibility of everything that's going on with the application and services managed by Consul. Now, Consul-Terraform-Sync, our next icon along, that is watching the catalog for any specific registered services. Let's say Consul is looking after my web front end and my app tier, but I might only want to be propagating information about that web tier front end to the firewall. Then I would tell Consul-Terraform-Sync, I just want you to watch out for any changes to web. Now, in this demo, we're going to show it's actually going to cover both of those tiers of the application and even manage communication between the two, because we want to be highly secured here in this cloud platform. But the gist of it being, Consul just has visibility of everything that's had a Consul agent deployed, which is just a single binary put in that VM or on that container host or wherever you need it to be. And then Consul-Terraform-Sync's job is to just watch for any change in state. That's its event trigger. So if I have 3 servers and I decide, you know what, I need to increase my scale group to 4 servers, then that scale group's going to spin up an additional virtual machine that's going to be allocated an IP address. Well, in this environment, because I have the console agent in that scale group template, it's automatically going to register itself with a console service catalog. Consul-Terraform-Sync that has been watching for events for that service is going to pick up that there was a change and repropagate that state through the Terraform provider to Panorama, which is then going to take care of all the firewalls that are relevant for that security. So the value here, it's not just that we've automated the propagation of state. Think a level deeper than that. The importance here is, first, we haven't had to wait for that change. Okay, so it's great that that's running a lot faster, and we haven't had to hope that someone wasn't a little bit too tight and put a typo in. So great, we've got reduction of risk, and we've got accelerated time to value of those revenue generating or productivity improving services. But then at the other side of things, we've also got elimination of a person to be involved in every change. So now the infrastructure is a system of orchestration. I like to differentiate between automation and orchestration. Again, automation's task-oriented. Orchestrated system, that is now I'm just managing a robust end-to-end solution here of everything that needs to be impacted and affected with all changes going on. Now that scale group was one example. I've added a new server to look after demand. Equally, what if a server failed? What if something happened? Maybe I was making a change to a server and I broke something. Well, again, because that console agent installed in that virtual machine is constantly checking the health and availability of that app, the moment something goes wrong, it informs the console catalog, this machine shouldn't be given traffic anymore, and that is immediately propagated. Again, that is an event, that is a change. So Consul-Terraform-Sync says, look, okay, one of them's gone, let's tell the infrastructure, we're gonna lock down, we're gonna take that out of the firewall policies now. So now I have an assurance that I've got fine-grained security instead of having to go loose-grained security on a subnet basis because I can't keep up with the workload. Now I can, because that constant change is automated. I can be fine-grained everywhere. I only have these specific endpoints I should get to in all of my policies, and it's because whether that was an intentional change like a scale group or an unintentional change like an outage, that is all taken care of me now, and my job is just to maintain my console cluster and Consul-Terraform-Sync. Did I miss anything there, Magara?
No, absolutely spot on. Just want to highlight the icons next to the Consul-Terraform-Sync. That's Panorama. That's the virtual Panorama that we're going to use during the demo today. So this is our management platform for all your VM series and CN series firewall. CN series, that's our containerized firewall, which can use to protect your Kubernetes-based workloads as well. And also you can see an on-prem firewall. So Panorama can, in fact, manage all kind of virtualized or physical that's running Panos-based operating system. And one of the key features that we're using, which comes out of the box, is user ID interface. So every update that Consul-Sync Terraform push to Panorama, we have the capability to push those tags down to all the firewalls managed by Panorama at that point. Not only actually managed by Panorama, as long as you configure that firewall to talk back to Panorama and consume the tags as a user ID agent, you can still leverage this Panorama. The nice thing here, the Consul-Terraform-Sync doesn't have to be configured to talk to individual firewalls. Now you might have 1,000 different firewalls. The nice thing here, your destination for Consul-Terraform-Sync is Panorama, and then from there we distribute near real time all those tags learned through Consul-Terraform-Sync to your entire firewall state. This is very powerful. Think about this, right? So you might have VM series deployed across multi-cloud. So based on a change that happened and the Consul service catalog discovered, okay, this specific tag belongs to this IP address. Now my entire state is aware of that IP address. This is truly powerful. Now you can write very granular policies. For an example, if these IPs belong to app group, block all that kind of traffic communicating out to the internet. So think about that. So that's what we're trying to demonstrate today.
Yeah, well said. That abstraction, from the Panorama and managing the bootstrapping of kind of adding more firewalls is a separate function to the workflow of what it is that's going into the policies. So that's a really powerful abstraction level going on there.
So
cool.
So just quickly want to highlight, this is one of a common architecture that we see for customers these days. Hub and spoke design, or you could call it transit VNet architecture if you want to be specific to Azure. So you got a bunch of firewalls in your hub. So bear in mind, these firewalls are not configured as your traditional head shape. So these are standalone firewalls. These can live within a VM scale set or a scaling group. So these firewalls can scale out and in based on your workload requirements. And usually you've got a load balancer in front. Any traffic coming in can load balance across these firewalls to protect your workloads. And you'd also notice there's a shared services spoke to run awesome tools like Vault. And in this demo, we are using HCS, which is also connected to our hub. So we are using HCS for service discovery. And on a management spoke, this is where all your management nodes live, such as Panorama, Consul-Terraform-Sync, or any other bastion host as well, if you want to maintain some of the stuff. So keeping that separation, right? And then on the right-hand side, you got different workload spokes. And also you can notice here, you can have a direct connect or a dedicated connection from your cloud service provider to your on-prem data center to provide connectivity to your on-prem services as well. Did I miss anything there, Nathan?
Yeah, no, good one. Just one thing I wanted to quickly call out on here. In this environment, we're actually using HCS, which is HashiCorp's managed consoles. So you no longer have to deploy and maintain that console cluster. This is a service offering both on Azure that we're using today, but also available on AWS as well, which means once you've deployed that, which is just a click button through a UI, we look after the any kind of patching upgrades that need, or scaling requirements that need to be looked after. And all you need to do is deploy that agent that in cloud platforms can discover where the console is just using platform tagging. So this is super easy to implement if you're not already an expert on sort of how service discovery and console works. It's merely an agent going into your virtual machine or your AMI images or whatever it is that you're using. And then you can start using this workflow. So this is, super simple to get up and running for customers.
Perfect. Before we dive into the demo, I just want to quickly go through a couple of more slides just to illustrate what are the kind of use cases we're going to use VM Series to protect against, right? So one of the use cases is inbound traffic. So the traffic coming into your workloads, right? This is where you would provide protection from external attackers breaking into your application. This is truly important, right? You talk about perimeter is all gone. So you need to make sure that any traffic hitting your web or any front-end servers are protected from these malicious attacks. And as important as inbound, it's really important to protect your outbound traffic as well. So this is where you secure your workloads, top data exfiltration. So for an example, let's say your front end get compromised, attackers usually try to exfiltrate data. It's really important to inject security through platforms like VM Series, so we can use advanced threat profile, URL profiles, things like that, to make sure we catch those attacks. And east-west is truly important as well. As I mentioned earlier, imagine your front end get compromised. Now, a common technique attackers use, the lateral propagation, right? So you start to move from one server to the other. So once they start hitting that jackpot or your crown jewels, they start to use data. So it's really important before they being able to propagate laterally, it's really important to enforce those security policies, which will show you guys in the demo today how we can maintain different dynamic groups, learn different IP addresses belong to different layers, and how can you write very granular security policies using application ID, which allows you to do deep packet inspection and things like that. Again, the same use case applies for backhaul traffic as well. Imagine your front end get compromised. You don't want your attackers to reach to on-prem data centers, right? So it's the same use case where you protect your east-west traffic. So that's a quick summary on the traffic profile. So let's dive into the demo. Let me
While you're switching screens there, I think the key takeaway from those 4 different flows of traffic and sources and destinations to protect, we're looking at multiple policies and sources and destinations. So obviously you want to secure all of those things, not just what's coming in from the internet, but that's a lot of parts. Like anything you can do to streamline and automate from a reliable source of truth is going to add huge value, because that's what's been missing from most infrastructure automation is what's my reliable source of truth? What is the state that I know is correct, that I'm not going to be in a constant panic when I push that live? And that's what Consul Service Catalog brings. That's that missing link from a lot of automation of how to get from a task-oriented, human-executed automation over to a orchestrated system where I know only the right things are going to be pushed into my policies.
Absolutely. So we are going to use Consul as part of the demo, of course. Currently, we've got a couple of services registered against this Consul service. We got a couple of app servers, and we got a couple of web servers running, right? So web server is your front end, and then app server, the web server connecting to app. So just to demonstrate 2 layers of the applications, right? We've got Vault configured to secure some of the credentials, which we'll go into a bit of detail later in the demo. So we're using Vault today to secure, leveraging the key value store to store some of the secrets securely. We've got Panorama, and we've got 2 firewalls. So Consul-Terraform-Sync is already running. I just want to quickly go to address objects. So these address objects are configured as dynamic address groups. So these are consuming those tags pushed from Panorama down to these firewalls. We are matching based on a tag. For this particular address group, we are using the keyword app. And for web, we are using the keyword web. We will later on go down into nitty-gritty details and show you guys where these are actually coming from. So now if you expand to find out what's being registered, now you can see 2 IP addresses registered against this app group. These belong to the app servers. So if you flip back into the Consul service catalog, you can see those 2 IP addresses, those 2 app servers registered against this address group. And it's same thing applies for web. So you have 2 IP addresses registered for the 1.5 and 1.6, which is exactly the 2 same IP addresses you can find here. So these information pushed from this Consul service catalog through Consul-Terraform-Sync into Power Firewalls. I also want to highlight what kind of rules we've got here. So you got an inbound rule, making sure that configured with web browsing. These are application IDs, which can perform deep packet inspection. So we make sure traffic hitting this rule, in fact, web browsing. So if the attacker tries to encapsulates some of the malicious data within web browsing, or if it doesn't belong as web browsing, we'll straight away deny that traffic. And outbound traffic is pretty much same. Right now, we have a pretty wide open rule. We can slightly change this during the demo and demonstrate how powerful these rules can be. And for east-west traffic, you would notice we only allow traffic from web to app server, not the other way around. So you can see that we leverage those dynamic address groups. So the addresses belong to these destinations. These are dynamically changed, right? So as the servers come up and down, and source get changed as well. If you think about 90s, the way we done it, we would have loved the entire CIDR range. We are not in 90s anymore. We need to, as you adopting zero trust, moving towards a zero trust model, you need to make sure you can define those granular security policies, restricted by that IP address per node, right? So that's the true power that we can bring with these kind of policies. So what we're going to do here, so right now we've got 2 web servers and 2 application servers. So what we're going to use Terraform to increase the number of web servers and app servers and see what happens behind the scene. So this should go do a Terraform apply. And while this is taking place, I want to also dive into what kind of things that you can obtain from these next generation firewalls. If I come in real quick here, I just want to highlight the power of application ID here. So you would notice that we have in fact detected some application called HashiCorp Console. So this is us detecting that gossip protocol that's going through the firewall. So just want to illustrate the power here, right? So we can be truly granular, even based on application. The next generation firewalls are capable to understand what kind of traffic I'm pushing through these firewalls. These are not IP port based firewalls anymore. We can write rules based on application IDs. If I go back into policies, you can see that actually, because I want this to be operational without too much restrictions, I just allowed pretty much all that HashiCorp-based traffic in this rule. And the same goes to other kind of traffic as well. You can see the applications, SSL, you can see web browsing throughout this demo, where very shortly when these machines comes up, let's quickly pop in here and see what's going on. Okay, you can see.
Mangara, sorry to jump in. Something I hadn't thought of before, because the console servers are also in the cluster, we could actually automate the creation of those policies of the console communications as well, as you just identified, and have that dynamically managed as just another option. I hadn't really thought about that one before.
Absolutely. And this is a power, right? Because Consul-Terraform-Sync, under the hood, you are using a special type of module called NIA modules. And under the hood, it's just using Terraform provider. So any resource that we expose from that provider, things like creation of rules, that we can certainly automate all that kind of stuff. We can create best practice rules. So for an example, when you're creating a Consul-Terraform task, you can hardcode, okay, for this particular applications, I want this type of security profiles to be configured. So you can be less restrictive on certain applications while being very restrictive on some other applications. So you can really use those kind of powerful features to automate not only security policies, but also profiles and things like that.
Cool.
So now we got the new application servers live. So console catalog discovered that. Okay, these are coming up too. So I want to quickly jump in here and do a quick refresh just to show you guys. Magic. So it automatically appeared in the dynamic address group. So those new servers now automatically push through Panorama into all the firewalls. So all the firewalls managed by Panorama are aware of these new servers just came out without any human interaction. That's the beauty of Consul-Terraform-Sync.
Yeah, that's awesome. And just to recap, that Terraform command, Megara executed in the right-hand side there, that didn't actually touch any of console. That was running the Terraform code for the scale group. You can see the Azure VM scale set. All we did was increment the variable of how big the scale set should be. So Megara just changed those two variables from 2 to 4, the default's 2. So then Terraform, using the Azure provider, just told those two scale groups, okay, you need to increase your size. That was the only thing that was touched here. We just changed the size of the application and the volume of elements in it. And the system itself, that system of console and Consul-Terraform-Sync communicating with Panorama, took care of all of that work to ensure that we still had a fine-grained policy that was actually defining what should be allowed to communicate.
Absolutely. Just real quick, want to jump into one of the application service that we just deployed, just to show. So this is one of the application servers. Right now, you probably can ping, you can ping into the internet, right? You can just browse web traffic, which is kind of dangerous, right? So just to demonstrate how easy to control this kind of behavior, if you go back into that outbound rule here. So this is an outbound rule. So this is pretty much allowing any kind of outbound traffic. So I can be very, very granular, and I can say, I only want to allow web browsing. And I can push those rules to all the firewalls managed within that device group. So from a click, right? So you're enforcing those rules on those VM series firewalls. You're making sure that in case your application layer get compromised, you enforce security on VM series firewalls.
In security, your job is to manage just policy and not to manage ephemeral IP address allocations, which really is just a distraction that's only gonna lead to typos, errors. I mean, in today's modern cloud platform, no one should be worrying about that anymore.
Absolutely. So while this policy getting applied, I want to just quickly zoom into the use cases we just discussed, right? So applying those granular application IDs into these policies allow you to allow certain kind of traffic. This might not necessarily be web traffic, right? If you have special kind of services running, you might want to create custom app IDs and making sure you are actually receiving the traffic you're intended to. And outbound, the same, making sure, for an example, you can, instead of saying any outbound rule, you can say, I only want to allow traffic generating from web dynamic group to the internet. So now, because you're pushing those updates through Consul-Terraform-Sync, you don't have to go and say allow from the /24 range or start typing in one IP after the other, because that's not going to scale very well when you have these applications configured as part of an auto-scaling group. Same principle for east-west traffic and the backhaul traffic as well. So now if I try to ping from my application server, I'm blocked because I applied a application ID on that rule, only allow web traffic. So if I try to call, still can. So that's the power of injecting VM series firewalls into your pod. enforcing those traffic, right? Those controls, making sure that you're truly secured. So while we are at it, let's actually do the reverse. Let's destroy those two web servers we deployed and also app servers we deployed, and see how this work out.
So this, now that you're no longer having to actually define individual addresses and sources and destinations, et cetera, I'm assuming that that allows you to have much greater standardization of policies. So you might know in your environment that any web front end is going to have a common set of policies you can develop now and just apply across the board, and then just attach a individual address groups per specific application after that. Is that a kind of a benefit you get from this as well?
Absolutely, absolutely. So what we're going to do real quick here is actually jump into the Consul-Terraform-Sync configuration so we can see exactly what's happening here. So we just want to quickly go through this, right? So the important pieces. So we are retrieving some of the credentials from Vault. So this block, of course, define that. Consul, this defines how to connect your Consul cluster. And this defines how to, what kind of driver you want to use. Today we are supporting Terraform, right? And then required providers, because we are using Panos provider, we specify what kind of provider we want to use there. And I want you to pay attention here, right? So these credentials are retrieved from Vault. So if I jump back in here, this password and username is actually securely stored in Vault, key value store. So what we're doing is pulling that credential, pulling those credentials from Vault into Consul-Terraform-Sync. And this is important.
This is super important, because the last thing you want to do when you create automation is make that the weak point, because obviously now this is the thing that's going and updating sources. Consul, I mean, in production, you always use encrypted communication between the agents and the servers. So that's all using TLS. So they all know and are able to trust each other, and you can't sniff that traffic. And then now Mago is just showing you the pipeline between Consul and Palo Alto is now also, we don't put any credentials in anywhere. You would have seen in the Vault block, it was empty because we're telling Terraform to push that into this virtual machine as an environment variable so that we don't even have to have, nothing's hard coded in any of this.
Absolutely. So this is where we define what kind of tags to listen to, right? So the Consul service catalog, the metadata coming from that into Consul-Terraform-Sync will contain this web and application tag. So we're making sure you're just kind of filtering it out and only grab that information and inject that into this NIA module. So NIA module is just another Terraform module expecting a special parameter called services. We'll post some links towards the end of this webinar, so go and check it out. Very straightforward modules with the addition of service variable. As long as you write them, your modules to accept that variable, you can use those Terraform modules with these tasks. So this is where Nathan mentioned about standardization, right? So you can really define as additional parameters for this particular application, I want these kind of rules. I want these kind of security profiles to be applied. And based on that task, you can standardize, okay, I want this kind of standardization on this task, and so on and so forth. So it's truly powerful. So you can really automate everything from this single place.
Cool.
So quickly want to jump back in. So now we have scaled in. We destroy those web servers. Now if I go and check it out here, they're gone. And the same thing here. If I jump into the other firewall, they're going too. So you didn't have to go and point into different firewalls. This is your Panorama 10306. So you're pushing these tags into Panorama, And from Panorama, you distribute all those tag information down to all the firewalls managed by Panorama at that point.
So now we have an abstraction level, both of the scale of the Panorama doing its job. You can add and remove additional VMs because they're bootstrapping out of Panorama and then getting their configuration state out of Consul. So that is just a non-issue now, scaling out that tier. Whatever changes, you can be very dynamic with how you're addressing that ingress. And then the same with the application, the state and current size, whether it's a failure or whether there's a demand increase, you can respond to without having to touch any of these things, but while knowing that you're doing it securely at all times.
Absolutely.
I got to say, Megara, I'm impressed. I might be biased, but I'm super impressed. Okay, well, do you want to, unless you had other things you wanted to show today, do you want to jump to the maybe the resources available for people to follow up, and we'll take some, see if there's any questions?
Absolutely. Let me stop sharing my screen real quick.
So first question I got from social media, do we share the same stylist? Is that a requirement to be good at network infrastructure automation? No, we just happen to look very similar. That's not a requirement to do network infrastructure automation. Let's find a more serious question. That was a good one, though. That's pretty funny. Okay, talk us through what you've got listed here, Megara.
Yeah, so here we got those top two links to the VM series modules, the modules we publish, professional services. So please feel free to use these, give us feedback. Contributions are welcome too. This third link is a module that we use today it's a network infrastructure automation module with that special parameter. So go have a look at it just to understand how these things work. It's just that extra parameter, and everything under the hood is standard Terraform. And the last link is a resource to Panos provider, so you can have a look at all the supported resources with that provider. So you can really have a look what kind of things you want to automate. So it's quite a bit we support today. So yeah, let us know how you get on, and happy to answer any questions.
So we got I have another question actually came in, which I think was a really important one. I don't know that I answered it clear enough earlier, but around that differentiation of like day 0 1 operations versus day 2. Obviously, when we build these lab environments, we use Terraform because we need to be able to blow it up, repave it, especially when you're experimenting and trying to work on things. You don't want to have to constantly be trying to get back to a good state from a known bad state. That is not the right way to come back. You reapply the known good state because templatization is key. That's what infrastructure as code is all about. That's a great way to build these environments, but I want to make it really clear that you can get this value we've showed you today without having adopted infrastructure as code. Infrastructure as code is definitely the future, but if you've got things that are deployed and you just can't bring an infrastructure as code pattern into your existing environment, you absolutely can still do what we've just shown you today. This day 2 operations is loosely coupled, very loosely coupled from the way the infrastructure has been deployed. If this is traditional static bare metal services and you've got your Palo Alto in front of it, which I hope you do because you want to make it secure, then you can absolutely still bring Consul and Consul-Terraform-Sync to that environment. It's merely putting an agent on that server so that it self-registers with Consul, and then you get all this value immediately. And we got a question just came in as well from Adam. Can you run by me the Vault piece again? How does the Panos provider know where to get the creds from Vault from? I noticed the Vault block that's a great question. We pushed it as an environment variable using Terraform to this machine so that we didn't have it stamped anywhere. That was a good eye there. Yes, that Vault block is empty because we didn't stamp it into the configuration file. But Consul itself actually has the ability to directly talk to Vault's API. It just needs to know where it is and the token for getting there. We've pushed that in as environment variables. For the purpose of this demo, you don't have to do it that way. It's just the way that we built it, because obviously every time we spin up this lab, Vault could have a different address. So we just pull it out of Terraform's output from Vault and stamp it into this virtual machine. So I hope that answers your question there, Adam.
Nathan, we had a few other questions. Can you use Panorama plugins with Consul-Terraform-Sync?
That's a great question. Absolutely. So Panorama plugins, just to set the context here for everybody's understanding, Panorama plugins are a set of special plugins that you can install on Panorama. So these plugins can configure in a way you can go talk to cloud service provider fabrics, pull out dynamic tags from those virtual machines and push it down to the firewalls. So absolutely, this is only going to complement Consul-Terraform-Sync. You can use this side by side, no problem at all. They're going to use the same interface, user ID, push those dynamic tags, and especially if you're using Consul-Terraform-Sync, if you don't want to step on each other's stores, you can even configure a special namespace, so you know what's being pushed from Consul-Terraform-Sync, and maybe maintain different address groups as well, and then operate side by side. Absolutely.
Awesome. Thank you, Megara. We have time for maybe one or two more questions. And where's the Consul-Terraform-Sync state stored?
So that state today. So for people who are familiar with Terraform, they're probably thinking, hey, I've got Terraform and I keep it in Terraform Enterprise, or I've got Terraform Cloud. As I mentioned, the state for this is actually Consul Service Catalog. So it's very different. We're not putting it like in the same place. So when Terraform runs and it finishes that job, its output, its state from that execution is stored in Consul's KV store. However, what's really important here is actually Consul's catalog and its constant communication from the agents, because I can nuke and repave that Consul-Terraform-Sync device. And when I bring up a new one, it's going to know from the catalog anything tagged with that tag that I'm concerned about and repopulate that through. So it's very easy to recover from. We're not reliant on that Consul-Terraform-Sync box being protected in a multi kind of device fashion. We are also working on supporting both Terraform Enterprise and Terraform Cloud as part of the roadmap for this technology for people who just want to put that state there. But right now, today, yeah, the most important state is actually Consul's catalog.
Thanks, Nathan. I think we have time for one last question from Spira. I assume that you can tie in these features alongside the Palo rather than strictly using Consul for discovery, i.e. load balancing.
Okay, I'm assuming then, yeah, this example we use service discovery where the agents are just populating their health and their location, address port information, and meta tags. We can actually use meta tags to make even more advanced, clever decisions in this process beyond just the address. For example, you may do A/B testing based on a tag that was in the catalog. That's absolutely a great example of this. So the question is, do we support some of the other use cases? So, I mean, typically there's service mesh, which is where we do kind of MTLS point-to-point communication by sidecar proxies. There absolutely is going to be cases where you need to have outside of that mesh, say a terminating gateway that talks out to the internet. And these are the kind of use cases we want to work on and help secure, cross-mesh communication, east-west, et cetera. These are some of the great use cases we're gonna continue to look at with our partnership with Palo Alto. But yeah, it's been GA'd a couple of weeks now. This is the first one we've come to market with. And yeah, hopefully the service discovery one is a great starting point for you.
Last question, does your CTS daemon has high availability?
So, yeah, I think I was kind of half answering that one as that one got typed in. The state itself, we don't rely on that virtual machine. In this case, it was just a Linux virtual machine, and we used systemd and we fired up the CTS daemon. Because it doesn't save its state locally, I can blow that machine up and just create a brand new one, and it will connect back into the Consul cluster which is where its state resides, and continue running. So, I mean, you could easily create a scale group of 1 and just have it auto regenerate. We're also looking at other ideas. We're interested to hear from people what model they prefer to support in their organization. But right now, none of the state's preserved inside that machine itself, so that it can be deleted and recreated and continue on working without an issue.
Great. Thank you, Nathan. Thank you, Megara. And I think that's all the time that we have. Thank you very much to the audience. Those were some great questions. I hope everyone enjoyed today's webinar and has a better understanding of network security automation with HashiCorp, Consul-Terraform-Sync, and Palo Alto Networks. And finally, as mentioned at the beginning, this webinar was recorded. We will make the recording available after processing. I will send an email to everyone who registered with the recording link. Have a great day. Goodbye, everyone.